Welcome everyone to today's webinar. This is day 2 of our series in Horizon4Aquaculture. Today we're going to talk about circularity and different progresses that we've been making in our 3 Horizon 2020 sister projects, Impact, Gain, and Efficiency. So my name is Dorothy Dankel, and I am a researcher in Responsible Research and Innovation, RRI, in marine science. I work in the Efficiency project together with many colleagues that are going to be speaking here today. So I am the moderator, and I'm going to guide you through our webinar. And we thank the people that already sent some comments and questions in our Padlet that we had on our Efficiency website. And I want to make everyone aware today that in this webinar, we have the Q&A button at the bottom. And at any time during the webinar, whenever you have a question or a comment, please use that. That is our connection to you, our audience. So another part of the Q&A is that you can upvote questions and comments, and that helps us also prioritize when we get to that point. So I'm going to welcome all of the panelists and the speakers today to the screen, and I will give just a quick introduction to our panelists. Our first panelist is Roberto Pastres, and he's a professor of ecology at the Department of Environmental Sciences and Informatics and Statistics of Ca' Foscari, University of Venice. And he's been focused on the development of modeling tools for the sustainable development of aquafarming. And he's the coordinator of the GAIN project, the Horizon 2020 project, Green Aquaculture Intensification in Europe. So welcome, Roberto. And then we have Frank Kane, and he's a marine biologist working in the aquaculture section at the Marine Institute in Galway, Ireland. He is doing research on aquaculture and management, integrated multi-trophic aquaculture, IMTA, and the development of novel and lower trophic species in aquaculture. And he is coordinating the Impact project in Horizon 2020. So we're going to hear more from Frank also later. And then we have Martina Ferreira, who is a biologist and has her PhD from the University of Santiago de Compostela in Spain. And she works at Onfoco Seco Pesca, which is a private non-profit business association founded actually way over 100 years ago in 1904. And they defend the sectoral interests of the seafood industry. We have our panelist, Silvio Cristiano, who's going to be talking later, as well as Inma Sanchez, who works as a circularity expert at Leitat in Barcelona. And for the last 10 years, she's been working on sustainability assessment tasks and the application of life cycle assessments. We're going to hear also more about LCA life cycle assessments from Daniel Checa, who also works at Leitat. And he's a junior researcher at the Circular Economy Department. And he is involved in LCA, eco-design, energy efficiency. We have great panelists today, so we look forward to this webinar. We have 3 sections today, 3 different topics. So the first topic we're going to talk about is the circular economy and the sustainability context. So first, let's get the context in place. And here we're going to have Roberto and Frank talk about the same call, but different scopes. Roberto and Frank, take it away.
Okay, thank you. Okay, thank you, Dorothy, and thank you, of course, to all people who joined us today. We are very happy that we had so many people following us, following this initiative. So I will describe to you a little bit the structure of the GAIN project. GAIN and Impact QT were funded on the same topic, which is ecological intensification of European aquaculture. It seemed mission impossible because we were asked to reconcile the increase in volumes and decrease in the environmental load of aquaculture and improving the sustainability of this sector. And as was said since the title, we interpreted the call into a very different way. In GAIN, what we thought was to combine together an improvement in the efficiency in the production, in introducing and implementing precision aquaculture, both for the filmfish and shellfish industry, and then improved the circularity of the industry by reusing as much as possible byproduct and side stream from a fish farm. Of course, this workshop is focused on circularity, and therefore, in the next session, some of the analysis and the processes that we investigated aimed at recirculating both biomass, which results from fish processing, and it is at present being underused, or used for other processes which do not add very much a lot of value to that, and also the attempt of reusing, for example, RAS wastewater, which is still rich in organic. So these processes will be described to you, and the sustainability will be assessed using LCA in one of the sessions. We also worked on other aspects of the aquaculture to improve the industry, for example, including in novel feeds also byproducts from other species aquaculture, producing other type of products which could have an added value, such as collagen, gelatins. And in the end, we try to put everything together by introducing a new index which should take into account a different aspect of sustainability, but also fish welfare. So this is all for me. You will, of course, get a lot of information during both this workshop about the project, but also in the next workshop on precision aquaculture next Tuesday. So I think I can give the floor to Frank.
Thank you, Roberto. And thank you, everybody, for joining this joint webinar series between the GAIN, the IMPACT, and the Efficiency Project. So I'll give a brief introduction of the IMPACT, which is a project working to develop an intelligent technological platform for the sustainable management of IMTA farms. The platform is to cover multiple production environments with the ambition to help validate the concept of IMTA as a novel aquaculture approach. There are 21 partners working in 3 key areas: an autonomous data acquisition and communication system, known as the IMPACT platform, an advanced IMTA model, and the intelligent management system. And these combine to form a sort of management structure for a complete holistic view. The project is working with 6 pilot sites in Ireland, Scotland, the Netherlands, Turkey, and China. And IMTA is the core circular action within the IMPACT project. It is a novel direction for European aquaculture. For context, I'll give you a brief outline of the concept of IMTA. IMTA involves the farming or aquaculture of species from different levels in the food chain or different trophic levels. The integrated element means that the species farmed are linked to each other in some way, serving complementary functions within the ecosystem. The idea is that the organic and inorganic waste from the fed species or the fish serve as nutrient inputs for other species, such as the filter feeders, the seaweed, or the benthic feeders. IMTA is a concept which can be applied at various aquaculture situations, with nutrient utilization in close proximity within a site, or on the whole bay, or even an area level. IMTA offers the potential to increase seafood while optimizing space, diversifying produce, providing alternative revenue streams, and having a lower environmental footprint. You'll hear more about the circularity and the sustainability as the webinar goes on. Thank you.
Thank you, Roberto and Frank, for those introductions to IMPACT and GAIN. So IMTA is an acronym I think we're going to hear more about today and in the future of aquaculture in a European perspective. So IMTA, as Frank described, integrated multi-trophic aquaculture. And our next speaker is also going to talk about IMTA in this sustainability context. Is IMTA circular and sustainable? So I welcome my colleague from Efficiency, but also Daniel is working in IMPACT, Daniel Checa from Leitat in Barcelona.
Thank you, Dorothy. Yes, let me share my screen. Okay, I hope you can see it. Well, I'm Daniel Checa from the chat. I'm going to talk about the impact project, continuing with the explanation of Frank, but this presentation more focused on the circular and sustainable related to the IMTA. So the first.
Sorry, Daniel, we don't
Yeah.
see your screen, your PowerPoint. Okay,
Can you see it now?
Yes.
Okay,
Thanks.
I'm sorry. Okay, so as I told, the first step is talk about the IMTA concept. Frank introduced it very well, but I'm going to talk about it more. The integrated multi-trophic aquaculture is the cultivation of the feed species together with extractive species, such as suspension feeding and deposit feeding invertebrates and macroalgae, which may feed on the organic and inorganic effluent generated by the feed species. The environmental benefits associated to the multi-trophic systems are that commonly related to the eutrophication reduction potential, mainly associated with the nitrogen and the phosphorus that flows within the species inside the system, the production system. And for example, going from the waste of the fish, those nutrients can be recirculated and captured by the other species like the seaweed and the shellfish, and avoiding this impact into the environment. Then for the sustainability assessment performed in the impact project, the sustainability of the IMTA is addressed under a holistic perspective. So for environmental vector, an LCA and an eco-efficiency assessment have been performed. For the social and economic perspectives, we have the cost effectiveness analysis and the socio-economic assessment that were carried out. Then for the ecosystem dimension, we have the ecosystem services assessment. And then finally, for the circularity, we have performed a circular economy approach analysis. Starting with the ecosystem services assessment, the ecosystem services assessment have considered different assessment methods, the Bayesian modeling, the monetary assessment of ecosystem services, and the correlation assessment. All of them were done to also identify which methods are suited for this type of assessment. And the results are that often there is an added value in terms of the provided ecosystem services when transferring to an IMTA system from a monoculture production system. Then the ecosystem benefits can be different depending on the type of the monoculture that was in place at the beginning, and also the size of the farm in relation to the local ecosystem. And finally, the environmental conditions of the area. So the local conditions are a key aspect to consider in this term. Then for the socioeconomic assessment, the socioeconomic assessment have shown that arising the IMTA with a better public image might lead to a easier access to the government issued operating permits and better relations with NGOs and local communities. Then IMTA has a significant contribution to local economy development in accordance with some of the basic IMTA goals, such as a positive local and regional economy impact, the avoidance of monoculture seasonality problems, taking into account local fishermen, etc. Then IMTA improves the potentiality for collaboration through network establishment and synergic action plans. And finally, most of the stakeholders are positive of participating in clustering teams in order to update their knowledge base, develop new products and research and development methods, apply new techniques for production, processing, etc. About the cost effectiveness analysis, results can be presented for both ABRA model and the cost effectiveness model, profit and losses and KPIs. But when focusing on the ABRA model results, we see that significant resources, as you can see in the left side of the slide, the significant resources efficiency improvements are in the fish feeding, the mortality removal and disposal, the environmental monitoring, and the record keeping to trace the conditions of the production and the cultivation. Then for the cost effectiveness model, about the profit losses analysis, 4 KPIs were selected. And as it can be seen as a result, the OPEX may increase the cost, but in terms of net profit overall, that is the KPI 3 in this case, turnover exceeds significantly the OPEX because of the fish production volumes that increase and the commercialization of the new species that are introduced in the same production system. After the COVID-19 pandemic era and the climate of uncertainty in the European fish market, prices in the fishery and the aquaculture sector are expected to rise. This, together with the improvement of survival rates provided by the impact platform and the increasing positive public attitudes toward the IMTA and premium sustainable products, can further increase the profitability of adopting IMTA as a production system. Then for the circular economy approach, after the assessment, IMTA production systems have been demonstrated to contribute to circularity in terms of nutrient recycling. So as a result, we have that IMTA systems has a circular pattern. IMTA platform notably aligned with circular principles as well. Then as an outcome of this assessment, there is an identification of activities, partners, and resources as key for a circular value creation, and an eco-friendly consumers market segment in the core of the circular value proposition. And finally, the circularity definition should be harmonized in the sector, as IMTA is recognized as a sustainable practice. Finally, for the environmental assessment, we have assessed the environmental impact in 6 pilots within the impact project. The first one is in UK, coastal aquaculture production provided by SAMS, in which they have seaweed and mussels. Then the second, Netherlands, offshore aquaculture production provided by North Sea Farm, and in which we have seaweed and mussels as well. Then in Ireland, a coastal aquaculture production provided by Marine Institute with finfish, seaweed and shellfish. In Ireland as well, an inland freshwater aquaculture production provided by Q Water from Marine Institute as well, with fish, duckweed, and algae. Then in Turkey, an offshore aquaculture production provided by Chamli with fish, bivalve, and seaweed. And finally, in China, coastal aquaculture production provided by Yellow Sea Fisheries Research Institute with bivalve, seaweed, abalone, and sea cucumber. And the results of the environmental assessment, here you can see two of the sea pilot results, one for fish, one cultivation with cultivation of fish, shellfish, and algae in the left, and in the right you have a pilot with seaweed and shellfish. So you have here the impacts of the monoculture scenario and how the impacts change after applying the IMTA. The impact categories selected were the climate change, the ozone depletion, the acidification of terrestrial and freshwater, ecotoxicity of freshwater, land use, resource use in energy terms, resource use about minerals and metals, the water footprint, and finally the freshwater eutrophication and the marine eutrophication. Here we see that the impacts for land use and eutrophication of freshwater, analyzing the monoculture conditions, the feed manufacturing is the main contributor in terms of plants proteins, soybean farming. And for the on-growing phase, has a notable contribution along the environmental profile due to the boat operation, the combustible, and as well the excretion of the fish in eutrophication of marine water. So in that term, IMTA can directly mitigate the marine eutrophication, impact by this nutrient recycling between the species. Then for the eco-efficiency assessment, the eco-efficiency assessment is a key element in the industrial sector, and it considers a holistic life cycle approach and incorporates both economic and environmental aspects. So all in impact pilots are able to increase their efficiency when IMTA is implemented. And specifically, all sites are providing more seafood protein to markets while reducing their pressure on the marine ecosystem. That means that we have more protein produced while we reduce the nutrient impact of the system. This is the figure in the left in both cases. And then on the other hand, IMTA enables an increase in biomass production by using the available space more efficiently by farming on multiple levels. This increase in biomass production within the area currently used for monoculture. So this provides greater biomass while reducing the environmental impact. So this is is represented in the figure on the right side in both cases. We have more biomass for the production and in terms of protein per hectare, using the same space, the same marine space or water space. The conclusions are that after a comprehensive sustainability assessment, we observed that environmental and socioeconomic benefits associated with the multi-trophic production and together with a cost effectiveness analysis, it concludes that impact platforms leads to productivity rise. In addition, after perform the ecosystem services assessment, it shows that the added value of IMTA systems in terms of the provided ecosystem services in comparison with the monoculture conditions. And finally, similarities with circular patterns are also observed in IMTA farms, providing the basis for developing circular business models around the IMTA products. And that's all. I don't know if you have any questions, you can write it on the chat. And after in the end of this blog, this session, I would like to give answer to these questions.
Thank you so much, Daniel. A lot of positive results for IMTA. Thanks for showing those to us. As Daniel said, use the Q&A. There's already a couple questions that have come in. We're also able to chat and answer these live, but there is a section at the end of this session after Silvio is speaking that we will have a panel discussion. So we look forward to that. I have several questions already, so we will have enough time. We have now about 10 minutes for our question and answer session with our panelists in this section about the sustainability context of circular aquaculture. So there's questions coming in, so thank you for those. Keep them coming. I'm going to ask my backstage assistant, Danny O'Brien, to open with the first question.
Hi, Dorothy. Thanks so much. Thanks to everyone sending interesting questions in. The first one that really is very interesting to me here, and I think it's an interesting challenge, is regarding IMTA within the framework of circularity. What are the risks then in a circular model for pathogen transfer or for drug residues from an ecotoxicology perspective as we go through the food chain?
Great. So risk for disease in IMTA systems. Daniel, would you like to answer that? Unless anyone else pops in.
I think that maybe in this case, under the sustainability assessment that we have performed, we haven't considered the disease aspect of the production, since we have analyzed the circularity and the sustainability of the production system itself. And how the inputs and the outputs in terms of materials, infrastructure, the energy, for example, for RAS systems inland, and the nutrients itself. I think that the key aspect that we have analyzed is the nutrient flow and how it can be assessed under a circularity perspective. So in this term, I think that maybe in the consortium could be other experts analyzing the disease and the biological welfare of the fish. But in this case, I don't have an answer.
Yeah, no, it's a really relevant question from Rafaela, very much an ecotoxicology question. Frank. Oops, Frank, just remember to unmute.
Sorry. Yeah, this is not a topic we address specifically within the impact project, but it is a question that has to be addressed about IMTA in general. I think as IMTA becomes a little bit more commercial and on a commercial scale, it'll be a little bit easier to see what's happening and the movement between them. But at the minute, it's a research question for scientists, which has to be clarified a little bit.
Okay, great. Thanks for that question, Rafaela. Danny, next question, please.
Thank you so much. I believe this might be a question directly to Daniel. regarding the difference in protein per hectare comparing IMTA and monoculture, you explained to us this, but we've got a question from Olga Olberg. How does it vary from year to year or season to season?
Yeah, about the production in terms of protein and the hectares used for the analysis, we have considered based on the different species that we had in the production system, we have considered a whole production cycle of these species. So we try to align all the species within the longer production cycle of the species, and then we associated the impacts with a continuous production based on this cycle. So this we have considered an homogeneous production in terms of productivity year per year, and based on the hectares of production.
Thanks for that, Daniel. One thing that I was wondering, just a quick question to Silvio, does the SHS dryer and the other dryer, I was just wondering what the technology readiness level of those dryers are. Is that something that already exists or something that now is still in the innovation stage?
Yes, I was mentioning that the average technology readiness level of both innovation is 6. So if they have been already developed, so their existing machinery, they have been tested at a real plant, so in Norway. So yes, they have been developed and they are ready. So cool. Yes, they are also, yeah.
Great, thanks for that clarification. Danny, next question, please.
Thanks so much. So this is a question regarding waste streams in particular, and how LCA within a circularity framework can address this tension. If using a waste stream can contribute to CO2 emissions, but not using it could contribute to eutrophication, how does LCA balance this?
I can reply if needed.
Thanks, Silvio.
Yes, so for its standard, its architecture, let's say, life cycle assessments allows to keep track of input output. So there is a mass balance. So especially when life cycle assessments are conducted like in scientific environments. So of course here the aquaculture's waste stream is treated as an input. So it is common to all scenarios. So we are going to see what are the end of life scenarios, but we are going to follow, let's say, the output, also the waste outputs, and see how, where they end up and how they are treated. So the reply, the answer is yes. We track where they go, and each different use after the water leaves the system is tracked. So if they go into water by this causing eutrophication, this is taken into consideration. If it is reused in different scenarios, this is considered as well. So there is a way to do that. In particular, for the innovations and the reference scenarios that I presented, there's no this kind of option because it is still valorized. It was valorized also before the innovation, but with less efficiency. But before then, and should it be released into water by the bodies causing direct eutrophication, that would be kept into, yeah, we could keep track of it.
Yeah, thanks for that. We can move on to the next question then, Danny.
We received a very nice question from Bernard Finesse. And the question is, can products produced under IMTA get an organic label? Can they be sold under the organic label?
Let's see, is that a good question for Roberto?
Mm-hmm.
Can IMTA products be sold under an organic third-party labeling system? Inma, you may also have some insights there.
Yes, I think that Frank has already answered that question on the chat. But mainly the IMTA system, I think that it's not currently recognized as organic standard practice. Although we are aware of the benefits in terms of environmental impacts, the organic standard doesn't provide nowadays guidelines for IMTA. And we also mentioned on the chat that particularly Marine Institute with salmon farming, they are working under organic condition, although they are a research site, so they are not commercial and they are not getting any certification to commercialize the products.
I have a quick question to Daniel. In the different ecological assessments that we're going, one thing that was coming to my mind, because we do know that one of the biggest barriers for or challenges to sustainability in aquaculture is from the feed. So in an IMTA system, was there a specific metric that measures if you have a monoculture finfish system, how much feed you use there compared to an IMTA system where how much less feed can be saved for the finfish? Was there a metric in your analysis on that?
In this case, the feed considered for the monoculture and the IMTA system were considered as the same because the finfish, for example, have to eat the same amount. But then after the uneaten feed, that we have a radio on uneaten feed and the excretion of the fish, we have a pool of nutrients that in monoculture are considered as waste. But then after introducing extractive species that consumes these nutrients that were considered as waste and integrate this for themselves, and we can take profit farming these new species, we mitigate the impacts of this waste.
Right.
So
yeah. So
the feed,
it's not going to be less.
Case,
yeah. The fish still have to eat, so that's obvious. But then the feed, any excess nutrients, that was the main point. That's you can have this more biomass, but less nutrient impact in the area, right? Exactly.
Yeah. And then another thing that we have considered is an extra scenario considering the impact platform with the more technological aspect that monitors the fish demands, the stress, and identifying when the fish have to eat in order to mitigate the feed losses, for example. And in this case, we have yes, we can say that we have less impact on the feeding.
Cool. Danny, I think we have time for a couple more questions before we move to the next section.
Great, thanks so much. This one's a very interesting one, and I'm sure there's a lot of perspectives on it. Has there been any integration of aquaculture with other local or related activities under a circularity model?
It looks like Silvio is typing an answer. While he's typing an answer, yeah, Roberto or Frank, do you have any insights here?
Yes, in fact, this is what we were aiming to do with Kane, in the sense that what we try to do is to investigate processes which could provide other sectors, other industries with added value or potentially added value components extracted from byproduct of fish processing. And now we are trying to liaise with different sectors, for example, with the cosmetic sectors, to see whether we can deliver to them from the aquaculture components such as gelatin, such as collagens, which can be used in other food industry sector or in cosmetic sector. And of course, this is what we meant to do since the very beginning. But now that we have the results, we are able to approach these companies.
Great, that's good to know. Daddy, if we take one last question in this round, not to discourage people from writing questions, because we have 2 more question and answer rounds, so keep them coming, but we'll take one more before we move on.
Fantastic. This is quite a specific one for the impact presentation. In the conclusion, it said that IMTA can serve as a base to expand the circularity of the value chain. The question is, which other circular patterns around IMTA do you consider to have potential for development in the future?
Is that one for you, Frank, or Daniel?
Yeah, we have identified the nutrient flow mass of the circularity for the mitigation of the impacts, but as well we have identified the impact mitigation for the infrastructure, for example, using elements that are reused not were introduced for the monoculture cultivation, and we don't need new elements to introduce the second species or the other species that came after that. So in that case, we have less impact for the nutrients, and then as well for the infrastructure elements that could be reused or taken into profit with the new species.
Great, thanks. I saw another question on socioeconomic stakeholder stuff. We have to get back to that, because that's, as a researcher in responsible research innovation, that stakeholder and socioeconomic context is really important. So I will definitely make a note that we'll get back to that. So thank you to the speakers in the first session on declaring circular aquaculture in a sustainability context.